Today we're going to get started doing some basic coding in Unity using C#. Some of the things we're going to be talking about are just general input and output, what that is, variables, using comments, strings, numbers, and also basic calculations. So this is just a little bit of background. I'm sure you've heard of this before, but just to make sure we're on the same page. Input is referring to something whenever a program is accepting data from an outside source. So it could be anything from typing something from the keyboard, moving a mouse, or capturing data from an outside source like a camera or scanner. In today's class, we are going to be having limited input just because of UI with Unity gets a little more complicated, but we will have some control over things. And we will be adding more actual user input in another class. Now, output is referring to the data the computer responds back to the user. So it can be all kinds of things. It could be using on-screen data or text, images, things like that. It could be printing something or even sound from the computer speakers. So for today, we're going to be using debug.log to display things to the console for now. Later on, we will be doing more things to communicate with the user. So with debug.log, if we wrote in our code debug.log hello world, then it would output hello world in the console. So the part that is inside the quotes would end up being written to the console. And I'll be demonstrating that again in a minute. So before we get started also, there's a few general things to keep in mind about working with C#. For one, it is picky. So you really do need to be precise and patience will be required. So if things don't work right away, look at your code to see if there's a simple typo, which really is often the case. Sometimes it's even just missing a semicolon. It's also case sensitive. So if you type debug log hello with a lowercase l, and it's supposed to be debug.log hello with an uppercase L, it'll give you an error. So when you're looking at things or typing things in, be very aware of typing in it exactly. Most lines are going to be requiring a semicolon at the end of them. There are some exceptions when we're creating a statement that has curly braces, for instance, loops, if statements, and you'll see where that goes. But in most cases, you're going to need to put a semicolon at the end of your lines. So it'll also cause an error if you miss them. Fortunately, Visual Studio will draw a little red squiggly line kind of to remind you that you're missing something. Also, if there's an open curly brace in your code, there must be a closing curly brace. So that's something people often miss if things aren't working. There may just be simply a missing closing curly brace or open. And another thing is that indenting really helps tremendously when you're keeping track of your code. So even though the program doesn't care if you indent or not, it can make a huge difference when you're trying to figure out what your code says. So I would recommend trying to keep your code tidy, and it'll just help you get through this a lot easier. Why make it more difficult than it needs to be? So one of the first things we'll talk about that is going to be a part of code is something called a comment. Now, comments are something that the program ignores anything after you do the comment symbol. So what's nice is you can make notes to yourself or another coder. You can make notes about functionality, and also you can comment out code if something's not working and you temporarily want the computer to ignore that section. So there are two ways you can comment. One is commenting out a single line. So in that case, the program will ignore lines that start with 2 forward slashes, and it won't run that part. So you could type pretty much anything. So for instance, in this little tiny 2-line program, I have a comment and I wrote display hello to the console. And so what that is just a note to myself saying that this is going to display hello to the console. So the computer actually just ignores everything that comes after these 2 forward slashes and then proceeds to run the next line. Another way you can do it is using block comments. So if you're going to be commenting out a larger section of code, instead of doing single lines the whole way, which you could do, you can use a block comment. And what you do is you surround your code with a / asterisk at the beginning of the part you'd like it to ignore. And to make it stop ignoring, you do a asterisk /. So if I did that, I could make a whole paragraph of things saying like, this is the code to hide, or, line that, or ignore that line too. So that's often when you want to make a section saying who wrote the code and what the date is and things like that. Or if there's a large section of code that you'd like to comment out and run it without that part running. Today, we're also going to be using variables. So last week, we just did a hello world. We just wrote some text to the screen. But today, we're going to be using something called a variable. And a variable is used to hold information. And it can really just hold one value at a time. It's kind of like a container or a folder that you could put something in. You would assign a value to a variable by using the assignment operator, which is the equal sign. So a single equal sign is actually called the assignment operator. And we're going to talk about a few basic data types. There are many more, but in this class, we're mostly going to be talking about integer, float, and string. So when you see int, that's referring to that I'm going to make an integer variable. An integer is a whole number, like 1, 5, 10. And an example of that is I would say that I am making an integer variable called score. So this is the name of the variable. Notice there's a semicolon. And then I can assign the value by saying score with the equal sign 1, for instance. And what it does is it always goes from the value is going to be on the right, and the container or the variable is always going to be on the left. So you can't say 1 equals score. It has to be the variable equal the value you'd like it to be. All right, so we can also do things with numbers with decimals, and then we would refer to them as a float. So for instance, if I had something with temperature, I could say temperature equals 97.5. Now in this case, we need to put an F at the end for it to not create an error. And it looks like I should have put in a semicolon there, so I'm just going to quick add that in. And the reason being is that there's also another data type called a double. And if you don't put an F, it's not sure what temperature is being assigned to. So since temperature is a float, we need to say that we're putting another float into it. And then there's also a string, which is a sequence of characters. So pretty much anytime you're typing text, you'll be dealing with a string. So for instance, I could have a string, I could call it first name, and the first name could be Fred, for instance. And then there's also something called a Boolean, which we will use later on in this school, in the other classes, and that's holding a true-false value. So for instance, if you're keeping track if your game is over or not, you could use a Boolean value, and I could set that game over is true, for instance. Now, when you're naming variables, you can name them all kinds of things, almost any name, but there are some rules you need to follow. One is that it must not start with a letter or underscore. So for instance, the variable called upside down and member name are okay, but for today is not. So notice that starts with a number 4. This would be not valid. They must also only contain alphanumeric characters. So an exception is the underscore character. So for example, you can't use any of these characters that kind of look like swear words in a comic strip in the name, but you could say your underscore name. That would be fine as a variable. It cannot contain any spaces. So if you want it to use a space, if you're using multiple words, either use an underscore in between or use uppercases to identify words for easy reading. So for instance, my underscore name would be fine, or my name, and notice I capitalize the N to make it easier to read, are okay. But you can't just do my space name. The computer would think that this is an individual variable and this is an individual variable. It doesn't understand that this is all one thing. So you need to either stick them together, oftentimes make the second or continuing words with an uppercase, or put an underscore under it. A variable also can't use a reserved word or a keyword. So for instance, and you don't run into this too much, but you can't use the word true as a variable or end as an variable. And there's some others as well. So if you run into a strange error and you're not sure what's going on, it might be a keyword that if you alter it, maybe it would make it work. So for instance, if true doesn't work, but I really wanted something in that to communicate that, I could change my variable to be is it true or the end. And by changing it, that would be fine. And notice this is all one word. I capitalized the first letter of each. And also something to keep in mind, variables are case sensitive. So if you make a variable called my name with a lowercase m and an uppercase n, and then my name with all lower cases, the program thinks they're two different variables. So things won't work the way you think they would. So what I would suggest is pick a formatting method and stick with it. Now, a very common one to do is the first letter is lowercase and then every additional word is uppercase. And that's something, if you just decide that's what you're going to do and stick with it, it eliminates some confusion later of what you're actually working on. So the very first time you use a variable, you need to declare it. Otherwise, it doesn't exist yet. And then you need to also specify what type of data it will hold. Once you declare it, the variable's type in C#, it cannot change. There are some other languages like JavaScript and PHP where it really doesn't care. You could put a string in there, and then later on you could put a number in there, and it just changes on the fly. But C# is very specific. So once you declare a variable's type, it can only hold that type of value. So for instance, an int variable cannot hold a string value. So if I wanted to declare a variable called score that I would be using later, I would say int, because a score typically is a whole number, and then I would write the name of the variable I'd like it to hold, to be named. Remember, you need that semicolon at the end. So at this time, this score doesn't actually hold anything yet. I didn't put a value in it, but score exists as a container, and it could hold a potential integer later. Now, another part of this is initializing a variable, and that's setting the initial value of a variable to something. So it's good practice to set variables to something, even if it's 0 or an empty string, just to avoid problems with unexpected values in code. And so you could do this on the same line as when you declare it if you'd like to. So you could say, for instance, score, instead of just saying int score, I said int score equals 0. So it starts out being 0. Or I could say string username is quote quote, and that creates an empty string. So string username will be existing, but it holds nothing. All right, one more thing to talk about here are access modifiers. So another thing you're going to be seeing is something where it'll say either private or public, and that's specifying if we want the variables to be accessed outside of the class that we're working on. We are going to be talking about this a bunch more later, but in today's examples, in Unity, if you make a variable public, you can access it within the inspector panel. And I'll explain that in just a couple of minutes. In general, you'll want to select if a variable is public or private. So private, here we've got a private integer called score, and we're setting it to 0. That means that score can only be accessed within the class. And in general, unless you need to make something accessible outside, you generally want to keep things private. Once again, more on that later. In this case, username here, public string username equals quote quote. That's setting up a blank string variable called username, but since it's public, it will allow it to be accessed outside of the class it's created in, and also in the Unity Inspector panel. And like I said, I'll be demonstrating that in a minute. So let's talk about string variables. And then after I describe this, we're going to actually do a couple of exercises in Unity. So with string variables, you can store and manipulate text. So for example, this will store a user's name in a private variable called first name. So if I said private string first name equals Jack, then that is taking Jack and it puts it into the variable first name. So once again, the variable is always on the left, the value is always on the right. Okay, so now I'm going to jump over to Unity. Let me get out of this presentation here. And I'm going to go ahead and start up Unity. So let me go to the Unity Hub. I'm going to make sure that I'm starting with the correct version. And for those of you who are in my class, I would say it'd be good to work along just so you can get the feel for where things are. I think you learn things a lot more if you actually do them versus just watch. If you need to do a step, what I would suggest is pause my video and then you can do the part you need to do and then continue on. So I just opened up Unity Hub, and what I want to do in this case today, I'm going to be looking for Unity 2019 for 2F1. Now this will work in other versions as well, but for fall 2020, that's what I'm using. So what I'm going to go is to new, but I'm going to do the pull down and make sure I'm using the right version. 2019 for 2F1. This shows all the versions I've got installed. So I'm going to choose that, and I'm going to make a new Unity project. And if you are in my class, there is a handout that gives the instructions that you can follow along. So I started a new Unity project. I give the name and such like that and what to do. So I am following that. You can use that as a reference. So I started a new Unity project. I'm going to name the project Variables Demo. The template we're going to be using is 3D. And in this case, it doesn't matter so much because we're not manipulating anything except working with the console, but I'm just choosing that. And the location, make sure to save it to somewhere you can find it again. In some cases, I would have a folder that called Unity Projects, and I'll save it in there just for ease of finding it. Right now, I'm going to save it to my desktop. I wouldn't do that for all my projects. It would just become a giant mess. So you might want to make a folder on your C drive and save it there. But for my demo here, I'm going to be putting it to my desktop. So I put it in my folder, desktop. It's called Variables Demo. And what it's going to be doing is actually making a brand new Unity project folder called Variables Demo when I hit Create. So it'll just take a minute to set up. And if it takes a little longer, I'll skip forward in my video. But it might take you a couple minutes. Okay, now that Unity is all set up, just a quick tour again of where things are. Right now, I've got the default layout. I'm just going to go back to default, make sure it shows default. Okay, so these panels can be moved around. I'm just going with default because that's probably what you would see. So quick tour, we've got the hierarchy panel over here, and that's going to show all of the game objects on the screen. Right now, we're not going to be doing much with game objects except attaching a script to it. Down here in the project tab, under assets, it's going to show all of the things we've created. So there's a folder for scenes. So right now we're working in the sample scene. We would put our scripts here, materials, things like that, prefabs. So all of that's going to be collected in that assets folder. And then over here in the inspector, it will show details depending on what we have selected. So since we're focusing on coding, what we want to do is make a new script and attach it to the object. So in my example, I say in the project window, click Create. It is now a plus sign. So that is the same as create. So there's a couple of ways of doing that. We can say here, and say I want to create a C# script, I can also right-click, create C# script. When that comes up, what I want to do right away without actually hitting enter first, because right now it gives me a default name, new behavior script, I want to go ahead and name it. So in this case, I'm calling it variable demo. One word, okay? And it should start with an uppercase letter just for naming convention's sake. But do not put spaces. I'm going to hit enter, and it's going to create a script for me, and it's going to have some pre-made sections to it. So that's kind of nice. So now what we want to do is go to the script, and also it kind of gives you a preview over in the inspector window of what this is going to look like. But what we need to do is run it and go into Visual Studio to edit it. So I'm going to go ahead and double click on my script, and it'll take me to Visual Studio. Now, if you just installed it this semester, it would come up with Visual Studio Community 2019, but if it's working in an older version, that's fine too. All right, so let me make my script a little larger here. All right, so as you see, my name of my file is here, variabledemo.cs. Now, if for some reason let me just jump over and show you this quick. If I were to make a new C# script and I hit enter, and then I go back and rename it. So right now it's new behavior script, and I go back and rename it, and I'll just call it test. Okay. Now if I go here and go into Visual Studio, notice my script is called test, but here the class is still called new behavior script. With the one I did properly, it says variable demo. Notice the class name is variable demo. Now it's really important that those match. So if for some reason you did it the other way, what you would do is just go here and change it within the class name. Otherwise, later on, it won't let you attach it to a game object. Okay, I'm going to not change it, and I'll use this as an example of showing you a common error of attaching if you run into that. Okay, so here's a little tour. We've got variabledemo.cs. It sets up this structure for us. It adds a few directives here to include some script libraries. So we won't be messing with this too much right now. It also sets up a class that will contain our scripts. And notice there's an open curly brace and a closing curly brace. So that needs to stay there, and that is defining the entire variable demo class. And we'll be dealing more with classes later. Now inside there's a couple of methods. And so if you've ever done programming, you've heard of functions before, this is very similar. So each one of these are their own. So one is called start and one is update. And those are by default created. And we use that in the Hello World example, where start is going to run one time. And so that's really where we're going to be programming today. Update would run once per frame, so potentially like 26 times a second. So we don't want our code to run that many times. You can either just leave and ignore the update section, or you can delete it. So it's up to you. For now, I think I'll probably just leave it alone. But I need to either delete this whole thing or just let it alone. Okay, so we won't be doing anything down there. And I want to point out there's already a couple of comments. Now notice there's a note. Start is called before the first frame update, or update is called once per frame. Now notice the 2 forward slashes, that makes the program ignore it. So if I remove those slashes, it'll not know what's going on there. Notice it's giving me some errors because that's not really coding. It's just a statement here. So I'm going to make sure that's commented out. Throughout this, I could actually make a note to myself, and I could put a comment in and say, this is just a demo of basic variables, for instance. And I could put a date in there. I could say who created it. Okay. And it's a good idea to just make a little note towards the top of your script, usually at the top, what's going on. Okay, and so everything that we're going to be doing today, adding in, is going to be inside of start. and inside of this class. Okay, so if you have that sheet that I have handed out to my class, you could use that as an example of what we're going to be typing in. If you don't, you can just follow along with the video. So the first thing I'd like to do is add 2 lines to the script that's existing already. So first, within the class, but after this curly brace, I'm going to be adding private string first name, and it's going to say Fred. Now, it could actually be whatever name you want to put in there, because we're just trying things out. So what this is doing is it's creating a private variable that's a string called first name, and it's taking Fred and it's storing it in first name. It's private, so only the things inside this class can access it. And we're putting it inside the class here and instead of the start method, because then if in the future, if we wanted to access it throughout other methods, we could. So a lot of times variables are put there. Now for the part that to display to the console, I have to put it inside of a method. I can't put my debug.log here. So let's put it where it would actually work first. So I'm going to be adding debug.log. And last time we did hello or world in quotes, but we can actually output what a variable's contents are. So to do that, I would write the name of the variable with a semicolon at the end. Okay, so what this is going to do is the program starts. It is going, in general, for the most part, it goes from top to bottom, unless you're calling different methods. So in this case, it's going to be setting up first name to hold Fred. When it hits start, it's going to run, and it's going to then write whatever's in first name to the console. So let's see if that works. So what I'm going to do is hit save. So I could go file save. Let's do save all. Or I could go Control S, and then I'm going to go back to Unity. Now, in the handout I have, there were a couple of steps that I skipped. I'm going to do those right now. In order for scripts to run, they need to be attached to something in the hierarchy. Now, since we're not doing anything really with game objects, we could simply just attach it to the main camera. Now let's look. If I take my variable demo, I can click and drag it up to the main camera to attach it. And I can make sure that it's attached by looking at main camera, going over to the inspector, and checking to see if that script exists. Now we only want it to be there once. If for some reason I dragged it there a couple of times and there's 2 of them, you can easily remove it by going to these 3 dots and saying remove component. So we only want the script to be there once. Now if you recall, there was that one that I had the error on, the test, when I tried to drag it. It's going to give me an error saying it can't add script component test because the script class cannot be found. And so it's saying that there's compile errors. Well, actually it's giving you a tip. The last version of Unity I saw gave more of a weird error and you couldn't know what it says. But notice it's giving us a clue. It says, and that the file name and the class name match. And that's usually what happens. So notice my class name is test. And if I went in there, the file name is test. But the class name was new behavior script. So if I were to change that to test and save it, and if I try to attach it again, it'll let me. Now notice I'm jumping between the programs. I'm using Windows. I'm just clicking between them down in the little bottom bar. Don't close your programs. You're really working between 2 of them. Okay. So over here, if I look at main camera, now I have 2 different scripts attached. I've got variable demo, which is what we want. Test, I don't want. So once again, if there's something you don't want, you can always remove that component. And in the end, if I really don't want this script, I can just delete it as well. So I can click on this and hit the delete key on my keyboard, and it says you can't undo this action, and that's fine. Let's just delete that thing. Okay. All right, so let's look. Back to this. I have a first name with Fred in it. I want to display it, and I attach that script to the main camera. So I'm going to go ahead and hit play. So there's this play button up top. And then what I need to do is go over to the console pane. So it's right here, and notice it says Fred because it's displaying the first name. Okay. So let me hit stop, which is essentially hitting the play button again. And I want to show you in the code, if I were to put first name in quotes, it wouldn't write Fred. Let me save this. Back to Unity and hit play. But instead, it says first name. So notice that if you want to use the value of a variable, you need to not put it in quotes. Okay, I'm going to go ahead and save that again. Okay. So let's do something a little additional. So let's say I don't want it just to say Fred. I want to actually have some sort of message with it. And to do that, we need to do something called concatenate. So I'm going to jump back to my PowerPoint and run this. So concatenation is really just sticking a couple of strings together. So when you hear me refer to concatenating or concatenation, it's really just joining them. And you use the plus symbol in C# for this. So for example, if I have two variables, I have first name, which has Susan in it, and last name, which has Retzer. If I wrote debug.log first name plus last name, it would write Susan Retzer. Notice it doesn't add any space. It just jams them together. So if we want to add a space, I would need to say first name plus, I would do quote space quote, I could put it right in there, plus last name. And so what it would have is Susan, which is first name, this is the space, and Retzer. Same thing here, if I had hello plus first name, it would jam it together. So another way you can do it, if I actually have a string that I've typed before a variable, I can just add a space at the end there, and it'll fix that. So this first part, hello space, is that first string, and the second one is the variable string. So let's check that out. I'm going to jump back to Unity and Visual Studio. And what if I change the debug log to look like this? So what if I go hello space quote plus and I'm doing a mistake on purpose here. I'll show you in a minute. So I have hello, first name, how are you? Notice I have plus signs to stick them together. And the spacing here doesn't actually make any difference at all. It's just easier to read, I think, to space it out a little bit. But notice I have hello space, Fred, how are you? Now if I run this, let me save it, go back to Unity and hit, oh, I didn't stop it. I need to then hit play. It says, hello, Fred, how are you? But it says, hello, Fred, how are you? Notice there's no space between Fred and how. So in that case, what I need to do is go here and make sure to add a space. In this case, I can just add one here, save it, go here, and I can hit stop and run it again. So it changes now to hello, Fred, how are you? So now let's go back to Visual Studio, and I'm going to change the word private to public. Okay, before I do that, let's look at the inspector. I'm going to go to the main menu or main camera, and notice in the inspector it just shows the variable demo script. It's kind of plain, right? So what I'm going to do is go back over here, and instead of private, I'm going to change this to public. Okay, I'm going to save it, go to Unity. I always forget to stop, so I'm going to hit play again. And it still says, hello, Fred, how are you? I'm going to hit stop. But I do want to point out, let's look at this over here again in the inspector. Notice now under variable script, there is a spot that says first name, and by default it says Fred. Now, the weird thing about Unity is that the variables seem to separate out the words. Instead of having it be one big word, it makes it look like there's a space. So don't worry about that. That's just something the software does. But what's cool is we can access this value directly. So I could change this to something else. Like I could change it to Tom, for instance. And what I can do is then hit play, and notice now it says, "Hello, Tom, how are you?" Okay, let me hit stop. So I could change this to Sandy. "Hello, Sandy, how are you?" So that's the beautiful thing about a variable. It changes, it varies. So instead of having something hard-coded, like we don't want to say, "Hello, Fred, how are you?" We can keep a value in a variable and it can be changed so that you can set up a display or scores or anything like that and then have it vary over time. Okay, so how about we talk about using numbers a little bit? So I'm going to go back to my PowerPoint and hit play here. So numeric variables would include integer and float, among other numeric data types. We're mainly just going to focus on both of those. And with those, you can add or subtract from your variable. So like I have an example like putting more change in a jar or removing it. But you can also do things like add to a score. So like, for instance, this example of score equals score plus 10, what it does is it takes whatever's in score, adds 10 to it, and then it assigns it back to score. So if we've got score, it adds 10, it takes that and then puts it back into the variable score. Or the same thing with character health. If we're talking games, we could see what the current character health is. So let's say it was 100. It's going to subtract 5 from it and then take that value and put it into character health. So now character health would be 95. So we can also do any kind of math statement. So we can set up figuring out a room area based on room width and length and calculate that and display it to the console. So in this case, it would be setting up a thing where it's making a variable called room width is 10, the length is 20, and then it's going to have room area, which is going to hold the final value. So I could calculate that by, it takes the room width, which is 10, right? So that's 10. Room length is 20. It multiplies those, so that would be 200. And then it assigns that into room area. Then it goes to this next line and displays it. So in this case, I'm displaying room area to the console. So debug log room area. So this is actually going to write 200 to the console. Now here are the mathematical operators you'll be dealing with. Addition is a plus, subtraction is a minus, division is a /, and looks like I need to fix my PowerPoint. Multiplication is an asterisk. So I will delete that in just a minute. But the multiplication is an asterisk. So that's not enough to derail everything. So let me quit out of this. And let's add a few things to our script. How about we're going to figure out how many years it is until somebody can vote. So what I'm going to do is add up here. I've got my person's name there. And how about I go ahead and I say private int their user age. And let's say this person is 10 years old. And I can say, let's say when you're 18, you can vote. And I want to figure out how many years left until they can vote. Okay, so here I've got my little program. Hello, in this case it'll be Fred, how are you? I'm going to enter. Notice I can add a lot more lines to my in between these curly braces, but I want to add them in between. And so how about I calculate the years left to vote, and then I'll display it. So I'm going to say, now this comment isn't required, but it just kind of gives a little note. So remember, you put the variable on the left and the value on the right. So if I want to figure out how many years there are left, I put that on the left, and I'm going to take the voting age, which is 18, minus how old they are, semicolon. So at this point, it will take, in this case, 18 minus 10, and it will put that value in here. And how about I display that result? You have the semicolon at the end. So what this is going to do is then say you have, notice I put a space here, plus whatever's in years left, plus until you can vote. Okay? It's going to stick all those together. What is nice is that with this, I don't need to convert this to a string in order to display it in the debug. It will be fine. All right, so let's run it and see if it works. I'm going to save that. Oops. Save. And if I hit play, right now I believe it still keeps Sandy because that's there. I could change this back to Fred. It'll change back. Notice that it was still running and I change it. It goes back to whatever the last state was when you hit stop. So I'm just going to go ahead and change this back to Fred. And I hit play. So it says, hello, Fred, how are you? You have 8 until you can vote. So I might want to add a little, change my wording here. So I could say 8 years until you can vote. That might make more sense. Let me hit stop. And also, right now I can only change the name. How about let's change the user age to public also, so they can change that. Once again, this is a rough way of having input. We will deal with a more interesting way, a more interactive way of having input later. So I'm going to save that. So I've got username public, or first name public, user age public. So when I go back here, notice now user age shows up as a slot in my inspector. So originally it was Fred and 10. So how about I have Jeff, and he is, let's say he is 16. And I hit play. Hello, Jeff, how are you? You have 2 years until you can vote. Now, if I were to put somebody in that is, let's say, 30, and I hit play, it'll give us a negative number, and that's okay. So here, hello, Jeff, how are you? You have negative 12 years until you can vote. So we'll be dealing with things like that later to deal with other options. But for this beginning example, it's fine. Now, another thing that I could show you, I want to just show you how update can do a running total. So I know I said don't do update, but I'm just going to do a quick thing up here. Let's say I put in private int score. And let's say the score of something starts out at 0, and that's fine. If I wanted to increment a score, which is common in a game, what I would do is go score equals score plus 1. So what this does is it takes whatever's currently in score, it adds 1, and assigns it to score. So in this case, it would hit this. 0 plus 1 is 1. It would assign it to score. Okay, now this is going to keep running. So it'll start out being 0, it'll become 1, put it in there, and display it. Now it's 1, so it'll be 1 plus 1 is 2, puts it into score, and it'll display 2, and so on. So that'll count up. Now it's going to go kind of fast. I'm going to hit save, go over to Unity, and show you what happens here. So notice it went past the other part really fast. Your score is now, we're already up to over 2,000. I'm going to hit stop. And if you don't want this to show every line, I believe we can hit collapse. Nope, in this case, it's not going to do that for us because each line is different. So, but as you can see, it's counting up. So it's just kind of a rough example of that. Now I want to show you one more example, but what I'm going to do is I'm going to say, hey, don't do this one. I'm going to paste it in and just give you the little tour of it, and you can just see what happened. If you'd like to type it in, you can, but I'm going to go ahead and replace the guts of my program here. Okay, so I can also do multiplication or division. In this case, it is dividing. So I wanted to show, for instance, I could use floats instead. So I could have the miles driven. I could enter the number of gallons. So essentially I could do a miles per gallon calculator. So in this case, I drove 10 miles and I used 1 gallon of gas, and both of those are public. So I should be able to enter that in the inspector. And if I wanted to figure out the MPG, once again, that's on the left. We have the miles driven divided by gallons, and then I can display that. So you drove miles driven on this many gallons, your MPG is this. So if I save and I run it, now the script's still attached, I just adjust this. So you drove 10 miles on 1 gallon. So once again, don't worry about that there's a plural there, it's fine. Your MPG is 10. Okay. Now there is a space that's kind of bothering me, so let me fix that. That would be right here. Notice it's gallons. That number was jammed right up against that text, so I'm going to fix that. But I've got these public, so let me save. What I should be able to do is over here, instead of in the inspector, instead of leaving it at 10 and 1 gallon, let's say I drove 350 miles and I used, I don't know, 12 gallons of gas. Okay, I can hit play, and now it'll say you drove 350 miles on 12 gallons. Your MPG is 29.16667. So because it's a float, it can deal with that decimal. So I just wanted to point out that you can also do multiplication, or I just showed division, not multiplication. But there's other things that you can do with this. So that is a quick overview on how you can use variables, comments, a couple of different types of variables. We did string, integer, and float. Public lets you show it in the inspector, and also how to concatenate.